For this question, it's asking about an elevator that is going up. It's being lifted 40 meters. We know the elevator is 1,300 kilograms. We know our change in height is positive 40 meters, and we know that our time is 75 seconds. It's asking for our power. So to calculate our power, we're going to have that our power is going to be our change in energy over our change in time. And this is what it's asking for in A. We know here that the only thing that was doing work, so the only thing that was changing our energy is going to be our EP, because all it was doing was going up. Our gravitational potential energy is changing. So therefore, we can say that our change in energy is equal to mg delta H, which is our gravitational potential energy, divided by our time. So we can put in our numbers here. 1,300 multiplied by 9.81 multiplied by 40 divided by 75. And we'll get 6801.6 joules per second, which is the exact same thing as watts. So we can change it into our significant digit, 6.0 times 10 to the 3 watts. For B, what it tells us is the power that the motor has to put in is 9.40 kilowatts. 9.40 kilowatts is the exact same thing as 9,400 watts, and that's what the motor has to put in. It's asking us for an efficiency, and we know that our efficiency is going to be our power that the motor is putting out divided by the power that the motor is putting in. So we know that our motor is putting in our 9,400 watts, and we know from this last question that our motor is putting out 6801.6 watts, which will give us an efficiency of 0.724 or 72.4%. And we can box up both of those. So this question is talking about a car traveling up a hill at a constant speed. First thing I want you to note, at a constant speed, that means our F net is going to be 0. So it wants us to draw a free body diagram right off the bat. So our free body diagram will start like this. I've just zoomed it in for a second so that we can see it really well. So here we are going to have an angle of 6 degrees, and we also have our car, which I'm just going to draw as a block pretty much, sitting there. We know the first two things that we have acting on that. We have our Fn, which is acting perpendicular to our slope. We also have our Fg. I'm going to draw it big just so it doesn't bang into my angle. We have our Fg right there. We also have two other forces it talks about. We have the red one right here, which I'm going to call our F applied. And then we have, going this way, we have our F air, which is our air resistance. The last thing that we would add on here is we would take our Fg and break it up into its components. So in blue here, I'm going to say that this arrow right here is going to be our Fg in a perpendicular direction. And I'm going to draw a blue arrow here as well and say that this blue arrow is our Fg in a parallel direction. And that is A, our free body diagram. The last thing I want to say about this free body diagram is Fg perpendicular equals mg times the cos of theta. And Fg parallel up here is going to be mg times the sine of theta. Okay, so I've just chucked our free body diagram up there at the top. For B, what it's asking about is it said what force is needed to maintain the speed. So what it's asking us for here is it is asking for the applied force to maintain the speed of that truck or the car that's going up the hill. In this case, we know that our F net has to be 0. So in a perpendicular direction, we can say that we know that our F net is going to be Fn plus our Fg in a perpendicular way. But in a perpendicular way, we don't care so much about what is happening, but we do care what's happening in a parallel way. So in a parallel way, we can say that our F net has to be equal to everything that's being added up in a parallel direction. So we know, I'm going to put them in the color that they are. So we know that in a parallel direction, we have our F app. We also know that we have our F air. And we also know that we have our Fg parallel. And we know that all of this has to equal 0. So if I say up here that I want this direction to be positive and this direction to be negative, the question told us that our air resistance is going to be 450 newtons, but I need to say that that's negative 450 because it's going in a negative direction. So down here, I don't know my F applied, it's still my question mark. But I do know that here what I'm doing is adding negative 450 newtons. I also know that my Fg in a parallel direction, it's also going in the negative way. So it is going to be negative of mass times gravity times the sine of my angle. So if I rearrange all of this, what I'm going to get is I'm going to get 450 newtons plus mg times the sine of my angle is going to be equal to my F applied. So I can put my numbers in now. So I have my air resistance, 450 newtons, plus my mass, 2,000 times 9.81 times the sine of 6. And what I'm going to get is that my F applied is going to be equal to 2,500.85 newtons, which I would say is the same as 2.50 times 10 to the 3 newtons. For C, because we know that the motor of the car is applying a constant force, we can say that we know that the power is going to be equal to that constant force times the average velocity. We just calculated our constant force, which is 2500.85 newtons, and the question gave us our velocity, and our velocity is 25 meters per second. So when we multiply those together, we are going to get 62521.2 watts, which we can say is the same as 62.5 kilowatts.